So far, we've discussed how to report significant figures, and we've talked about accuracy of our results. Now we're going to talk about how to measure these results properly. So a mathematical approach that we're going to be using is called dimensional analysis. And this is how we can convert units. Um, So we have to be able to convert units properly in a lot of different chemical formulas, equations that we work on in this class. Uh, a conversion factor or a unit conversion factor is the ratio of two different quantities, and we express that ratio with different measurement units. So we can write 2.54 centimeters is equal to an inch. We can write that as an equivalent statement, as a ratio, or as a fraction. So 2.54 centimeters equals 1 inch. We can write 2.54 centimeters over 1 inch. And what happens is this just equals 1 uh, because it's the same thing. It equals the same amount. And so we can write these as one amount. We can write this as centimeters on the top and inches on the bottom, or inches on the numerator and centimeters on the denominator. Here are some common conversion factors for length, volume, and mass. We're typically going to be changing grams and kilograms, liters and milliliters, and maybe some other quantities as well. Um, Centimeters and meters, I believe, is another common quantity from these equations that we do. Let's look at a very simple unit conversion problem. So here we want to convert 34 inches to centimeters. So we're going to write our starting value here, and then we're going to multiply it by our conversion factor. And your starting value, whatever that is, the conversion factor, we want those units to be the same as our starting value, because inches and inches end up canceling. So if we multiply this across, we would get inches on the top and inches on the bottom. Inches divided by inches equals 1. So we can cancel inches and inches. And so now we just have 34 times 2.54 centimeters divided by 1. This 1 just so happens to be a 1 for this, but if it was not a 1, we would still divide by whatever that value is. So written as a fraction, our final answer would be that. But 86 over 1 is still just 86. Conversion of temperature. Water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius. The Fahrenheit scale, it freezes at 32 Fahrenheit and 212 Fahrenheit. We probably won't be using Fahrenheit too much in chemistry, but that's just some facts to know. And 100 degrees Celsius covers the same temperature interval as 180 degrees Fahrenheit. Again, the Kelvin scale, water freezes at 273.15 Kelvin and boils at 373.15 Kelvin. And 0 Kelvin is the lowest temperature that can theoretically be achieved. So we say that's absolute 0 or 0 Kelvin. Here are some formulas on how to calculate Fahrenheit and Celsius. Now you can solve this algebraically for what Celsius is. You can subtract 32 on both sides, and then you can multiply by 5/9, and you would get the Celsius equation instead. You can also just plug in whichever value that you were given. So if you're given Fahrenheit and you want to convert it to Celsius, you can plug in the Fahrenheit value as is with this equation, and then just solve algebraically for Celsius. And then this is our Kelvin and Celsius conversion. This one's a lot easier. So Kelvin is equal to whatever degrees Celsius plus 273.15. And this is kind of a neat way to see these reference points on a thermometer between these. So water boils at 212 degrees Fahrenheit, 100 degrees Celsius, and 373.15 Kelvin. So these are all the same values. Freezes at 32 Fahrenheit, 0 degrees Celsius, and 273 Kelvin. And then negative 40 degrees Fahrenheit just so happens to be negative 40 degrees Celsius. And then we just subtract 40 from our 273 Kelvin to get 233 Kelvin. All right, and here are the practice assignment questions for this section.